Assalamu alaikum. Today our topic is types of matrices. First one is row matrix. Any matrix is called row matrix if it contains only one row. As you can see here, matrix A, it contains only one row. So we can say that matrix A is row matrix. Similarly, matrix B also contain only one row. So we can say that matrix B is row matrix. Next type is column matrix. Just like row matrix, column matrix must contain only one column. So here matrix A contain only one column, so we can say that matrix A is column matrix. And here matrix B is also column matrix since it contains only one row. Okay. Next type is rectangular matrix. In rectangular matrix, the matrix number of rows and number of columns are not same. Okay. As you can see here, number of rows are 1, 2. Two rows and 1, 2, 3. Three columns. So its order will be 2 by 3. Number of rows are not equal to number of columns. So we can say that matrix A is rectangular matrix. Square matrix is just opposite to rectangular matrix. These definitions oppose. In square matrix, the number of rows and number of columns must be same. Okay. As you can see here, number of rows are 2 and number of columns are also 2. So its order will be 2 by 2, that is row into column. So here rows and columns are same. So we can say that matrix A is square matrix. Next type is null matrix, also called zero matrix. As its name shows that the matrix, all the entries of matrix must be 0. Since all the entries of matrix A are 0, so we can say that matrix A is null matrix or zero matrix. Similarly, all the entries of matrix B are also 0. So it is also a zero matrix or null matrix. Our next type is transpose of a matrix. While taking the transpose of any matrix, we simply change its rows and column. We interchange column into row and row into column. Here consider this matrix. We will take transpose of matrix A. Transpose is denoted by small English alphabet T. Here A transpose will be equal to, its first row is 1, 0, 2. So we will change this row into column. Like it is 102, we will write it like this 102. So we have interchanged row into column. Okay, now we will do the same with the second row. It will be 2 minus 1, 3. So we have changed row into column. Okay, so this is A transpose. Now the next type is negative of a matrix. As its name shows, we will only change the signs of a matrix while taking the negative of any matrix. Consider this matrix A. While taking the negative of a matrix, we will simply change the signs, or you can say that we will multiply the given matrix by minus sign with negative sign. It is 3 minus 7 minus 2, 8. Now we will take its negative, so it will be minus 3. Here it is plus 3. While taking the negative of matrix, it will be minus 3. And it is minus 2. So here it will be 2. It will be 7 and it will be minus 8. We have simply multiplied this matrix with negative sign. Here you can see, I will do one step for you. Negative A is equal to minus. And here A matrix is 3, minus 2, minus 7 and 8. So now we will multiply this negative sign with the matrix. Minus plus minus 3. Minus minus plus 7. Minus minus plus 2. And minus plus minus 8. So we have obtained the negative of a matrix, as you can see here. Okay. Next type is identity matrix. As the name shows, in identity matrix, all the diagonal entries are 1. All other entries are 0, but diagonal entries must be 1, not other than 1. Identity matrix is represented by capital I. Okay, and here since this matrix is of order 3 by 3, so we can say that it is I3. Here 3 shows that number of rows are and number of columns are equal, and it is 3 by 3 matrix. Basically, in identity matrix is also called as square matrix because in here number of rows are equal to number of columns. Similarly, I2 will be equal to 1 0 0 1. This 2 shows that order of this identity matrix will be 2 by 2. Clear? Okay. Our next type is diagonal matrix. Here again its name shows diagonal. It means that diagonal entries, all the entries must be 0, but diagonal entries will be other than 0, non-zero entries, okay? And in diagonal matrix, at least one diagonal entry must be different from other entries, okay? Like this is diagonal matrix, this is also diagonal matrix because it is here it is 1, it is different from these two, okay? In diagonal matrix, all the entries are 0, but diagonal entries must be non-zero. And in diagonal entries, at least one entry must be different from other entries of diagonal entries. Okay. Next type is scalar matrix. Scalar matrix, here all the entries are 0, but diagonal entries are non-zero. Okay, here I will give you some tip. Some students didn't understand the difference between diagonal matrix and scalar matrix. So here you can remember it by my district tip. D stands for diagonal and D also stands for different. So it means that diagonal entries must be different. At least one diagonal entry must be different from other two. Okay, so thus it will be diagonal matrix. And in case of scalar matrix, here S for scalar and S also stands for same. So you can say that diagonal entries must be same in case of scalar matrix. Okay, and all other entries must be 0 in both case, as you can see here. Okay, so I have ended with my lecture, and for watching more videos you can subscribe my channel. Thank you.